Hello everyone, myself Hans. Today we are going to solve the problem of beta gamma function from integral calculus. Here in the question, show that integral limit is 0 to 2 and x bracket 8 minus of x cube whole power 1 by 3 dx is equal to 8 by 9 gamma 1 by 3 into gamma 2 by 3, and we can also prove that is 16 pi upon 9 root 3. Let's solve the problem. Given integral is, this is given by I is equal to 0 to 2 and this is x into 8 minus of x cube, 8 minus of x cube की whole power 1 by 3 dx, and let x cube is equal to 8t, and from here we get the value of x here. This is x is equal to 2t to the power 1 by 3, and we can also find the value of dx here. Differentiating, this is dx is equal to 2 times of differentiating t to the power 1 by 3 with respect to x. This is 1 by of 3 and 2t to the power of 1 by 3 minus of 1, this is given by minus of 2 by 3. 3 1 ja 3 and minus of 3 plus of 1, this is minus of 2 by 3, and this is given by dx is equal to 2 by 3 t to the power of minus 2 by 3. And we can also change the limit here. When we have to put, when x is equal to 0, we get t is equal to 0, and we get x is equal to 2, we get t is equal to 1. So we have to put here in the given integral, that is I is equal to 0 to 1, and in place of x we have to put 2 t to the power of 1 by 3 into 8 minus of, in place of x cube we have to put 8t and whole power of 1 by 3, and in place of dx we have to put here into 2 by 3 and t to the power of minus 2 by 3. Here is dt is also present, so we have to write dt, and further we can solve. This is given by integral I is equal to 0 to 1, and from here 2 2s are 4, this is 4 by 3, and t to power 1 by 3, this is 1 by 3 and minus of 2 by 3, this is given by 3, taking LCM here, that is minus of 1 by 3. So we have to write t to the power of minus 1 by 3, and we can take common from here 8, that is 1 minus of t की whole power 1 by 3, and this is dt. And further from here 8 is taken to the outside, we get I is equal to integral limit is 0 to 1 and 4 by 3 into t to the power of minus 1 by 3, and from here we have to take outside from the cube, this is 2, and this is given by 1 minus of t to the power of 1 by 3 dt, and further we can also write, this is given by I is equal to 4 2s are 8, 8 upon 3 is taken to outside, and integral limit is 0 to 1, and here is t to the power of minus 1 by 3 and 1 minus of t की power 1 by 3 dt, and further we have to change into the beta function. This is beta function is given by beta mn is given by integral limit is 0 to 1 t to the power of m minus of 1, and here 1 minus of t and minus of 1. First we have to convert in the form. This is given by 8 by 3 and integral limit is 0 to 1, and we can write t to the power of minus 1 by 3 is written as t to the power of 1 by 4 minus of 1. Once again 1 by 4 we get minus of 1 by 3. Once again minus of 1 by 3 is written as 4 by 3 minus of 1. This is written as 3 by 4. Once again, we get minus of 1 by 3. Minus of 1 by 3 is written as, once again, 1 minus of 2 by 3, and we can also write 2 by 3 minus of 1. 2 by 3 minus of 1 we can write here. The value of t to the power minus 1 by 3 is written as 2 to the power of 3, 2 by 3 minus of 1. When we take LCM, 3 1 is 3, this is 2 minus of 3, this is minus 1 by 3, and here 1 minus of t, and we can also write 1 by 3 in the form of 1 by 3 is written as 1 by 4 minus of, once again, 1 by 2 by 3. Once again we can write 1 by of 3 is written as 4 by 3 minus of 1. 4 by 3 minus of 1 we can write, we get 1 by 3, this is written as 4 by 3, and this is once again 4 by 3, this is written as 4 by 3, and minus of 1, this is dt. On comparing with the beta mn formula, this is given by 0 to 1, tm minus 1, 1 minus of t, and power n minus 1. We can also write this is I is equal to 8 upon 3, and this is given by beta 2 by 3 comma 4 by 3, and further we have to expand. This is given by integral I beta mn is given by gamma m into gamma n and gamma m plus of n. So we have to expand here. This is 8 upon 3 is already present here, and we have to use here gamma m. This is gamma 2 by 3, and gamma here gamma n is 4 by 3, and upon 2 by 3 plus of 4 by 3. This is written as gamma m plus n. Further we have to solve. This is given by 8 upon 3, and from here we can also write 2 by 3, gamma 2 by 3, and gamma of 4 by 3 is written as gamma 4 by 3 is written as, once again, 1 plus of 1 by 3. 1 plus of 1 by 3, this is gamma n plus 1 is written as n gamma n. So we have to write 1 plus of 3 plus 1, this is gamma 4 by 3 is written as gamma 1 by 3 plus of 1. So, and gamma of 2 by 3, once again, gamma of 2 by 3 is also written as gamma, once again, 1 plus of 1 by 3. So we have to write gamma 2 by 3 as usual, and gamma 1 by 4 is written as gamma 1 by 3 plus of 1, and from in the denominator here taking LCM, this is 3 and 4 plus 2 is 6, and this is given by gamma 2, 3 to the 6, and the gamma 2 value is 1. Gamma 2 is written as gamma 1 plus of 1. So we have to explain this formula. This is n gamma n, this is 1 gamma n, and the value of gamma 2 is 1, and the required is I is equal to 8 upon 3, and from here this is gamma of 2 by 3, and we can also expand the formula. This is gamma n plus 1, we can write n gamma n. This is written as 1 by of 3 and gamma 1 by of 3. This is 3, and further from here we can also multiply here. This is 8 upon 9, and from here is gamma 2 by 3 into gamma 1 by 3. first part we have to prove, and we have to prove the second part. Further we can also write, this is, once again, this is 8 upon 9, and gamma 2 by 3 is written as, using the formula, this is gamma of 1 minus of n, and gamma n is written as pi upon sine n pi. We have to convert gamma 2 by 3 in the form of, this is written as gamma 1 minus 2 by 3, once again 1 minus of 1 by 3. 1 minus of 1 by 3 we can write gamma 2 by 3. This is on taking LCM, 3 1 ja 3, and 3 minus of 1 is 2 by 3 we get, and here is already gamma 1 by 3, and we can write gamma 1 minus of n, and gamma n is written as pi upon sine n pi. So we have to write here integral I is equal to 8 upon 9, and we can write here pi upon sine n pi. Here is the value of n is 1 by 3, so we have to write here pi by 3, and we know that the value of sine pi by 3 is root 3 by 2, root 3 by 2. So we have to put here, this is given by 8 upon 9 into pi upon root 3 upon 2, and we have to further solve. This is given by integral I is equal to 8 upon 9 into pi, and taking 2 is into numerator, 2 upon root 3, and this is given by I is equal to 8 to the 16, this is 16 pi upon 9 root 3, and this is the required solution of the given problem. We have to prove the second part also. Thank you class, and thank you for watching.